Hello guys, welcome you all for this End-to-End AIML program where we're going to learn everything that you guys need to become a successful data scientist. I hope you guys are enjoying this session. I think it's more than 20 plus days. So hope you guys are enjoying each and every day. So we are also enjoying. So and let us know if you guys are facing any difficulty, just put it in the comment. So we can there to help you guys, help and guide you. So before coming to the session, please guys, please make sure that you have watched to all the videos that we have posted before so and come to this session. Okay, so I think 4 days before we have started a new topic like machine learning. Okay, in that we are just discovering different things. Last session is all about clustering. It is one of the unsupervised learning. Today we're going to see one more unsupervised learning technique, that is dimensionality reduction. Okay, so hope you guys have watched all the previous video, and yeah, let us dive deep into this session. Okay, so now unsupervised learning, dimensionality reduction. I think you guys have already know about what is dimensionality reduction. I think we have stressed this point in 2 or 3 sessions, I think so. So let's see what it is. Unsupervised learning is a type of machine learning where the model learns from the unlabeled data. This means the data does not have any predefined categories or labels. The goal of unsupervised learning is to discover patterns and structure in a data without any prior knowledge. So yeah, this thing we already know, right? Unsupervised learning means the model will learn itself without explicit data labels. Okay, the model doesn't know whether it is an apple or mango. Just it will use the characteristics and it will classify. Okay, cluster. Okay, we doesn't need to tell classify because classify is supervised. Clustering is unsupervised. So whenever the model is just using the features in order to find the category, then it is called as clustering. Okay, so that is what unsupervised learning. Coming to dimensionality reduction is a common task in unsupervised learning where the goal is to reduce the number of features in the dataset while preserving the much information as possible. Okay, I will put it in a simple manner. Dimensionality reduction means, consider in a real world scenario, you are having a dataset of 1,000 columns. Okay, but do you think all the 1,000 columns is important for you to build a model? No, right? We will just take only 10 columns which are very important in order to build the model. So not that we are leaving a remaining 990 columns, but the 990 columns remaining have an ability to be represented by this 10 columns itself. So what we're gonna do means we're gonna find only the important only very important features that we can use, okay, for model building. Instead of going for all the 1,000 data set, all the 1,000 columns in the data set, we can only use just 10, right? So that way we can reduce the number of features. So this is what the dimensionality reduction is doing. Yeah, that is what all about dimensionality reduction. Yeah, sir, over to you.
Yes. So welcome each one of you guys. So go through all the sessions 5 to 10 times, do reinforced learning, absorb the information, digest, and then apply. Do all the assignments which we have given, and write in the comment section whatever feedback, whatever improvements you want in these sessions, so that we'll continuously improve and bring new aspects in AI, ML, and data science. So and also subscribe to our channels and press the bell icon so that you will get notification for each session. So let us learn today unsupervised learning, dimensionality reduction. So we have already reinforced on this particular topic as Raja has already mentioned. So unsupervised learning is type of machine learning where model learns from unlabeled data. That is the first point you need to remember. It learns from the unlabeled data. Okay, it is kind of machine learning. So this means that data doesn't have any predefined categories or labels. We have not labeled, okay, and there are no categories. So the goal is to like unsupervised learning to discover patterns and structures in the data without having any prior knowledge. Okay, so uh, this will bring new innovative ideas, guys, new innovative insights. Unsupervised learning, na, it will bring a lot of insights, innovation, new disruptive innovation ideas in your model and in the industry wherever you are applying. So, but data should be pre-processed, cleaned, EDA, all the things should be done. It should not be non-biased. everything, because garbage in, garbage out for data or your health also. If you eat healthy food, you will be having healthy life, healthy body. So if you have junk food, you will have that kind of body. So that is also data. So that is biological data, and ultimately turning into molecules and energy, ATPs and stuff. But here it is building model and it is also data. So dimensionality reduction is a common task in unsupervised learning where the goal is reduced to number of features in the data while preserving the much information as possible. So we have to remove the features which are not necessary. So this is how you need to remember dimension. Some dimensions we reduce. That is what is dimensionality reduction. So we reduce some dimensions from the data which are not relevant uh, and which will not impact the model. Okay. So that is what it is. So let's move to the other slide.
Yeah, guys, sir is mentioning like this dimensional reduction is a reduction of higher dimension to lower dimension. So that's a baseline that we can do. Okay. Yeah. So moving on, dimensional reduction techniques. Okay, let's see. Okay, why dimensionality reduction? Reduces dimensionality reduction reduces computational time and resources, improves data visualization and interpretation, prevents overfitting in machine learning models. We will come one by one. First is reduce computational time and resources. It's true, right? Instead of going for all the 1,000 columns, we are going for only 10 columns. So time is reduced because training time, because in order to train this 1,000 is completely different from 10, right? And it also requires resources. Okay, for CPU or GPU resources, it's gonna take very less resources. Then improves data visualization and interpretability. Yeah, right. We need 1,000 dimension to visualize the data. Instead of that, now we need only 10 dimension to display the data. Okay, so visualization will be very easier. Then prevents the overfitting problem in machine learning models. Yeah, that's also true, because like if you think 1,000 features you're gonna train a model, then model will be like memorizing everything. So now we are stopping that, so that overfitting problem will be reduced by using this dimensional reduction. That's another thing. Yeah, let's see what are the types of techniques we are having. One is linear techniques, like we are having PCA and LD, principal component analysis, and then linear discriminant analysis. So another thing is non-linear technique like t-SNE. I think we have discussed this. I think okay. So it comes under both the things. Let's see t-SNE, and then autoencoders. It is also one of the dimensionality technique. Feature selection method that selects a subset of the most relevant features. Okay, here we going to find only the relevant feature from the available features. Okay, that's it. Next, selection criteria. The choice of techniques depends on the specific dataset and the intent use case. Okay, this dimensional decision purely depends on the dataset what we're gonna use, and based on that we need to find the things. Okay, so keep in mind, guys, this is gonna be like when we are implementing, it's gonna be crazy, guys, because like we're gonna have 1,000 features and it's gonna convert only to 10 features, but those 10 features will replicate all the 1,000 features. Consider like how it is doing, like, so that's the reason. So this dimensional reduction has a capability of reducing computational time and cost, resource, and improves the visualization, as well as it will avoid the overfitting problem. Okay, so yeah, sir, over to you.
Yes, rightly said by Raja. So this is great. So we are enjoying these sessions, guys. Are you enjoying? Write in the comment section. Give us feedback. So dimensionality reduction technique. So why we use it? Okay, why reduce dimensionality? Why we use dimensionality reduction techniques? Okay, it reduces the computational time and resources, improves the data visualization, portability, and prevents overfitting in machine learning models. So these are that is why there is always why we use computers, because it computes different kind of data, different things. It helps us to optimize our. So why is the first thing why we use dimensionality reduction technique is it reduces computational time, resource, improves data visualization, interpretability, we can interpret easily, we prevents overfitting of machine learning model. And then types of techniques, linear techniques like PCA and LDA, nonlinear techniques like t-SNE, and autoencoders, feature selection models that select the subset of most relevant features. So these are the techniques which we use in dimensionality reduction. And then selecting the criteria. The choice of technique depends on specific dataset and the intended use case. So whatever is your problem statement, whatever your problem statement is for, so you have to use these techniques according to that and the characteristics of the dataset. So it depends on specifically in the dataset and the use case, whatever is your problem statement. And you need to do a good research on problem statement. Like it's I would call it a mini project, because if your problem statement is not clearly defined, so you might end up collecting wrong data and processing wrong data, or then cleaning and EDA and selecting wrong model. So it depends on, guys. So each dimension of your pipeline depends on each factor, and it begins with the clearly defined problem statement and use case. And according to that, you will collect data and use techniques and models. So this is how we use different techniques and models. And these are the benefits of DRT. Okay, I will call it DRT, dimensionality reduction technique. So these are very powerful tools, guys. Absorb it, digest it, and apply to all the assignments. And write in the comment section what have you learned, how you're going to apply, and what is your objective function of learning these sessions. Write that also. And let us move to the other session.
Yes, sure. So moving on, we're going to see one by one. Okay, PCA guys. So PCA means principal component analysis. Let's see how it's gonna reduce the dimension. Okay, of 1000 to 10, anything. Okay, linear transformation. PCA finds a set of orthogonal axes that captures the most variance in the data. First of all, it will go and see the data, visualize it, and it's gonna see how much variance in the data. Then data projection. The data is then projected onto this axis, reducing the dimensionality of the data. So if there is a multiple dimension, it will try to project the data into some set of directions. Like consider we are having 1000 dimension, and what PCA will do means it tries to fit the data or project the data in only 10 dimension and tries to find whether it covers all the data. That 10 axis we are having here, right? Whether it covers all the data which are covered by the 1000 features. Okay, that's the thing. Then principal component, the axes are called as principal component and represent the direction of maximum variance in the data. That's it. Okay. So what this PCA will do means, consider we are having data set and it is represented by 1000 features. Now we need to reduce it to the 10 features which is projected. These 10 features are projected by PCA, and this 10 features which is projected in the direction is called as principal component. That's it, right? So I think this is the easiest way of explaining this thing. So yeah, that's the thing. So try to understand in just in a breathwise manner, guys. While we are going for a coding session for PCA, you're gonna learn lots of things related to PCA, because like I will say like a technical term, eigenvalue and eigenvector. Don't worry about it. We are here to help you and find you and reach a state where you can learn these technical terms. Okay. So eigenvalue, eigenvectors are the important thing which can find the direction of PCA. But this time you guys need to understand what this algorithm will do. That's it. Okay. So yeah, sir, over to you.
So, PCA, again, principal component analysis, it is a technique we use it in dimensionality reduction, guys. So, linear transformation, we do linear transformation, which is PCA finds a set of orthogonal. So, you guys, can you write in the comment section what is orthogonal? Orthogonal is involving right angles at the right angles. So it's a statistical word of or involving right angles of the right angles. So that is what is orthogonal. So PCA finds a set of orthogonal axes that captures the most variance in the data. So right angle of the right angle, right? So this is the linear transformation. This is how linear transformation happens. So then projection. The data is then projected onto these axes, the right angle of the right angle, reducing the dimensionality of the data. Okay, so we reduce the dimensionality. So why we reduce the dimensionality? Because uh, there would be features which are not relevant. So we reduce those and we keep the relevant ones which are as per the objective function of the problem statement or use case, right? So whatever is our right now we are in weak problem solving, weak AI. Not, we are not in general AI or in a super AI. Their definitions change, guys. If you use PCA there, because then in general AI you need general data also, right? You can't have, so in super AI you need huge amounts of data, right? So that you have to solve big problems. So here we are using this in a weak AI. So in general AI you have to upgrade yourself when general AI will come. So principal components, the axes are called principal components, represent the directions of maximum variance in the data. So this is how we use PCA, and these are the things, okay? The meta level we have made understand that why you, what is PCA? It finds orthogonal axis, which is a right angle of the angle. It finds the captures the most variance in the data. That is what it does. It captures the most variance in the data, okay? And then data projection, it projects onto these axes whatever data, reduces dimension of data, okay? And that happens in the black box, so we'll go into that. We'll use functions and all because that happens inside the model, that is not shown to us, okay? So principal component, again, the components are the axes which are called the principal components, represent the direction of maximum variance in the data. Those are called principal component. That's why it is called principal component analysis, okay? From there it has, the nomenclature has come from there, okay? So keep learning deeply and keep applying this knowledge, do all the assignments and watch all the sessions 5 to 10 times and press the bell icon and subscribe to our channels. Keep learning deeply, have patience, and have objective function, long-term objective function for your career. Become a lifelong learner. Let's move to the other section.
Yeah, moving on to the next slide. Yeah, guys, another thing. Okay, linear discriminant analysis (LDA). Before going for this, I have a question. This PCA and LDA comes under dimensionality reduction of which model? Linear model, right? So I have that in mind. Okay. So next we're gonna see linear discriminant analysis. This is LDA. The same thing we're gonna do here. Supervised dimensionality reduction. The reason is LDA is a supervised technique that aims to find a linear transformation that maximizes the separation between two classes. Okay. What this LDA will do means it will have a line. Okay. Consider we are having a data points. It will have a line and it will try to separate the line so that like it will separate the data. So if we are moving, aiming and transforming, so that the maximum separation between the lines will be high. Okay, the line will be there and then the data points will be two sides or three sides, anything. So whenever the maximizing the separation between the data points, then it becomes a clusters like a dimensions. Okay, like those things will happen. Class separation, LDA finds a set of axes that best discriminate between the different classes in the dataset. That's a true thing, guys. Okay, whenever this LDA comes and best discriminates, so that what happens means it will differentiate two different data in a very easier and a very good manner. Okay, very good manner. Okay. So this LDA is very important in order to reduce the dimension. As I am speaking, like if we are maximizing the separation between two classes, what happens means its dimensionality will be reduced, right? So that's the thing. And then for class separation also, it will provide a best discrimination so that different classes in the data can be predicted. Okay. Next, application. It is very very useful for classification task and data visualization task, because higher dimension to lower dimension, right? It we can now plot the diagram, plot the data. Okay, effective when there is a clear class structure is in the data. Okay, so it is effective in what manner means we should have a proper class structure defined with data. Okay, so this is what all about LDA, linear discriminant analysis. It is one of the type in the dimensionality reduction, which is under the unsupervised learning. Yes, sir. Over to you.
Yeah, so rightly explained. So LDA is linear discriminant analysis. So what we do is, if you understand, focus on the name, it discriminates the data. Simple. You need to see it will, and now we'll see that. Okay, supervised dimensional. So it is a supervised learning dimensionality reduction technique. So is a supervised technique that aims to find linear transformation that maximize the separation between classes. So it discriminates, it separates. What discrimination is? What you discriminate, you keep separate. So if you see the actual meaning of the word, it is discriminate means separating. Like if you have heard this word in society, people say you discriminate me, you separate me, means it means you separate me because you're not keep thinking we are one, you're separating. So this is, you have to use it, it's very simple, huh? So it separates between classes, that's it. And it is a supervised dimensionality reduction technique. Okay, then class separation. LDA finds set of x's that best discriminates between different classes in the data. Again, there would be features based on that it will discriminate. It is not it will discriminate any data. It will discriminate based on the data features. Okay, and the applications used for classification tasks, data visualization effective when there is a clear class structure in the data. Again, I already said it proactively that it needs to have a clear class structure when you are discriminating. So when it discriminates, it needs to have a clear class structure. So you can't discriminate. You can keep certain points here and there. You need to have a clear class. Okay. And these are the things. So let's move to the other slide.
Yeah, sure, sir. So, guys, like today we are having this much content. Okay, so I hope like today is like a overwhelming session will be for you, because like we have introduced one more concept in unsupervised learning, which is dimensional reduction. We have looked into three different parts of this course, and then we have looked into what is PCA. Now we have seen LD, and we have seen a couple of lots of algorithms also in a linear and then non-linear also. We will continue in the next session. Hope you guys have enjoyed this session. If you guys have any doubts, just ping in the comment. Otherwise, see you all in the next session. Please like subscribe to our channel, press the bell icon so that you will get notified whenever we upload the video. Keep learning, guys. Keep learning, keep exploring, and we will meet in the next session. Bye, guys. Till then, bye.
Bye bye, guys. Take care and do the reinforced learning and absorb the information, digest the information, and apply the information. Do all the assignments. Only come to this session when you complete all the previous sessions properly, huh? With patience and consistency, with objective function. What do you want to become? Write in the comment section. What do you want to become after doing these sessions? There should be an outcome, whatever time you're spending, right? On the social media and everywhere. Here we are learning for your career, for your growth. So write the objective function of your career. What do you want to become? And what is your long-term objective function in your life, so that we'll add a lot of value. Give us feedback how we can improve, and we'll be there to help you. Thank you.
Yeah,